Hello everyone, this is teacher Justina and welcome back to my channel. If you are still new, then do not forget to subscribe, like, and share for more video updates. Our topic for this video is all about derivatives of any function using the chain rule. Okay, so let us proceed to the definition of the chain rule. The chain rule says that any composite function, which is h of x is equal to f of g of x, and its derivative is h prime of x is equal to the derivative of the outer function times the derivative of the inner function. So let us try explore this example. So number one, so we are going to follow what is the definition of the chain rule. It says that the derivative of the outer function. So when we say outer function, we simply apply the power rule. So the power rule says that our power should be written as our coefficient of the expression, and then always subtract 1 to the exponent. So we have 3 minus 1, and then times the derivative of the inner function. So our inner function is 5x minus 4 and its derivative is 5. So to simplify this further, we can multiply the 3 and the 5. So we have there the 15, and then we have to have the 5x minus 4 to the power of 2. Well, anyway, we can still expand the 5x minus 4 quantity to the power of 2 times 15. Well, anyway, this still could be considered as our final answer. Let us have number 2. So number 2, our outer function is 7 times the 5x cubed plus 2x squared minus 4x, but this is already 6 because 7 minus 1, and times the derivative of the inner function. So the derivative of 5x cubed is 15x squared, and then 2x squared is 4x, and the negative 4x is negative 4. To further simplify, we can only multiply the 7 and this expression. Why? Because it has an exponent of 1 as overall. So therefore, we can simply multiply or distribute the 7 to its term. Thus, we have this 7 times 15x squared. We have the 105 x squared. The 7 times 4x is positive 28. And the 7 times negative 4 is equal to negative 28. And you just uh, write this expression next to this. Well, anyway, you can still consider as this 5x cubed plus 2x squared minus 4x quantity of 6 can be written ahead of this expression. Okay, let us have this example number 3. But I want you to observe that number 3 is made up of two factors. So we have the 2x plus 3 and the x minus 4 to the power of 3. So this time, we will be using or we will be involving the derivative using the product rule. So in this case, we have to set this as our first function and this will be our second function. But before that, we will be getting the derivative of its first function. So we have the 2x plus 3 as our first function and its derivative is 2. To get our derivative of the second function, remember that our second function is x minus 4 to the power of 3. And this time, getting its derivative, thus we will apply the chain rule. So the chain rule says that the derivative of the outer function, so this will become 2 already, times the derivative of the inner function. So the derivative of x minus 4 is already a 1. So final derivative of our second function is 3 times x minus 4 to the power of 2. So this is our g prime of x and this is our f prime of x. So let us now start getting the derivative of our function. So therefore, this will be derivative of our f is uh, writing the first function as is. So our first function is 2x plus 3 times the derivative of our second function. Remember that this is our derivative of our second function. So 3 times the x minus 4 to the power of 2. So therefore, that will be our uh, f of x times the g prime of x plus our g of x is x minus 4 to the power of 3 times our f prime of x, which is a 2. So let us now find out as to how to simplify this further. So as you have seen that there is a common in each term. Remember that this is our first term and this is our second term. So, how do we find out the common factor? So, as you have seen, we have here an x minus 4 and x minus 4 in the second term. So, therefore, to simplify this further is to get its common factor, which is x minus 4 and to the power of 2. Why I am using the 2? Because uh, it is the expression with the least exponent will be our common monomial factor. So therefore, this will be this entire first term divided by our common monomial factor, which is x minus 4 to the power of 2. So simply, we're able to have this as 1. So what is the remaining term inside? We have 3 times the 2x plus 3. Remember that if you will be multiplying them back, if you multiply them back this one, if you multiply this to this one, we will be coming have this expression back. So therefore, we are going to continue. Uh, we are going to have the next, which is uh, x minus 4 to the power of 3 times 2 divided by x minus 4 to the power of 2. So therefore, remember there is a 3 in here, and then according to the law of exponent, we have to subtract their exponents if we will be dividing common bases. So therefore, we have to copy the plus there, plus, and then since there is a 3 and there is a 2, so we have the remaining x minus 4 to the power of 1 and a 2 there. Okay, so for this, remember that if we multiplying them back, we will be getting this entire expression. So how to get the next step? Okay, we just simply copy the x minus 4 to the power of 2. And then we can simplify the inner expression. So we can multiply the 3 here. That will be 6x plus 9 and a plus 2 times x is 2x and 2 times negative 4 is negative 8. So for that, we can have now x minus 4 to the power of 2. Then the 6x and the 2x can be combined, 8x, and positive 9 times, not times, but plus positive 9 plus negative 8 will give us a sum of 1. So therefore, this is our derivative in number 3. Okay, so let us proceed to number 4. So as you have seen, the expression is can be differentiated by uh, getting the derivative of the outer function. So this 5 will be written in here. So this will be 5 times 3x squared plus 1 over 2x minus 1. And so far, the 5 will become 4 because it will be minus 1. And this will be multiplied to the derivative of the inner function. So our inner function is 3x squared plus 1 and then over 2x minus 1. And then as you have seen, our inner function is expressed in a quotient form. So if it is expressed in a quotient form, thus we will be getting its derivative out of this formula. So, but before that, we will be getting the derivative of our first function. So our first function there is considered as the numerator, and our second function will be our denominator. So the first function, f of x, is being described by the expression 3x squared plus 1, and its derivative will be 6x because 2 times 3, so that will be 6x. And then the second function, g of x, is equal to 2x minus 1, and then its derivative will be 2. So the g prime of x is equal to 2. So since we will be multiplying the derivative of the inner function, we will be getting first its derivative. So using the formula, so the derivative, so d over dx of 3x squared plus 1 uh, over 2x minus 1 is equal to g of x refers to the denominator, so 2x minus 1 times the derivative of the f, or the derivative of the first function, which is 6x, minus, so it's minus what? F of x, and our f of x is 3x squared plus 1, and then times the derivative of our g, which is 2. Okay, and this is all over 2x minus 1 to the power of 2. So to simplify this further, we will be distributing the 6. So 6x to 2x, so this will become 12x squared, and then that will be negative 6x, and the 2 will be distributed first. Thus, this will be 6x squared plus 2, and then this is all over 2x minus 1 to the power of 2. And for that, we will be simplifying this further. 12x squared minus 6x, and then that will be negative 6x squared minus 2. And this is over 2x minus 1 to the power of 2. And there are terms that can be combined, and they are the 12x squared and the negative 6x squared. Thus, it will give you 6x squared, and then minus 6x, and then minus 2. And this will be over 2x minus 1 to the power of 2. So meaning, this is our derivative of our inner function. So for this, we will be multiplying this to the derivative of the outer function, 6x squared minus 6x minus 2 over 2x minus 1 to the power of 2. So let us now further simplify them. Remember that the outer function's derivative is this, while the inner function's derivative is this. And then so far, we can now simplify this further by what? By writing it this 3x squared plus 1 over 2x minus 1 quantity to the power of 4 can be written in this manner. 3x squared plus 1 to the power of 4 all over 2x minus 1 to the power of 4. They are just of the same concept. And then times we will be also having this 6x squared minus 6x minus 2 over 2x minus 1 to the power of 2. And then as you have seen, uh, we can uh, we can only multiply the 5. We can distribute the 5 in here. That's it. Okay, because remember that we cannot multiply the 5 or distribute the 5 in here because we have the power of 4. But instead, this one has understood power of 1. Okay, so to simplify this further, we can now multiply the 5 and the 6x squared. That will become 30x squared. And then that will be 5. Okay, that will be 5. Okay, 5 times negative 6x will become negative 30x. And then 5 times negative 2 will be negative 10. And this will be over. Remember that we have common bases. Thus, applying the log exponents, we simply copy the common base 2x minus 1, and then we will be adding their exponents. So 4 plus 2, this will become 6. And then so far, if you will have to factor out the numerator, the 30x squared minus 30x minus 10, this could be factored out by what? Um, this could be factored out by a common, which is a 10. And then if 10 will be our common monomial factor, this will become 3x squared minus 3x minus 1. And then all over 2x minus 1. But still factoring them, I'm sure that if this 3x squared minus 3x minus 1 can be factored out, but still it's no use because the 2x minus 1 to the power of 6 don't have any common if ever this 3x squared minus 3x minus 1 has factors. So therefore, this could be considered as our final derivative of that number 4. Okay, so again, this is our final derivative of our example number 4. Okay, so let us proceed this example number 5. Okay, so we are still to get the derivative of the outer function, which is the 4 will be written in here. So 4 times the square root of x over 3x plus 1, 10 to the power of 3 already. And then times the derivative of our inner function. So our inner function will be the f of x. Our f of x is this. Okay, and this is our g of x. So getting its derivative, but we still have to rewrite the square root of x, and then so as to apply the power rule, we will be expressing it to x to the power of 1/2, the fractional equivalent of the square root of x. So its derivative will be, so writing the 1/2, okay, and then in here, written in there, and then x to the power of 1/2 minus 1. This will give us negative 1/2. So this is our derivative of our function f. Let's proceed to the function g, and this is 3x plus 1, and thus its derivative is 3. So therefore, since we will be getting the derivative of the inner function, now we have to note that our inner function is expressed in a quotient. So we will be using the quotient rule, finding the derivative using the quotient rule. Okay, so we will be having d over dx of square root of x over 3x plus 1 will be equal to, as the formula says, the g of x, meaning the second function or the denominator. The function of g will be written as is 3x plus 1 times the derivative of the first function. The derivative of our first function is 1 half times x to the negative 1 half, and then minus, so it's minus, our f of x is x to the power of 1 half, okay, times the derivative of our second function, which is 3, the g of x derivative. And this is over 3x plus 1 to the power of 2. So to simplify further, we will be distributing this 1 half x to the negative in here. So this will become 3 times 1 half will gives us 3 halves. Okay, and remember that the x is a power of 1 and the x here has a negative 1. Thus, we will be adding 1 plus negative 1 half. So what is 1 minus 1 half? So that will give us positive 1 half. Okay, after which we are going to distribute the 1 half x to the negative 1 half to 1, and it will gives us positive 1 half x to the power of negative 1 half. Okay, and then the 3 will be multiplied to x to the 1 half, and that will gives us 3x to the power of 1 half. And this will be over 3x plus 1 to the power of 2. Okay, so next step is we will be combining similar terms, and so far they are similar in the sense that they have same literal factors. So x to the power of 1 half, and the x has a power of 1 half. So for that, we will be adding the 3 halves and the 3, and then remember the 3 halves, okay, then the minus, then the 3 could be expressed into 6 over 2. Why I have chosen the 6 over 2? Because, and where did I get the 6 over 2? We can simply multiply, no, the shortcut. Um, 2 times 3 will gives us a 6. And since this is a 3, we just simply copy the 2, so 6 over 2. So in this way, we can easily combine the numerator because they have the same denominator. This is another way of getting the least common denominator. So 3 halves minus 6 halves will gives us negative 3 halves. So this will be negative 3 halves, then copy x to the 1 half, and then followed by this one, positive 1 half x to the negative 1 half, and this is over 3x plus 1 to the power of 2. And for this, we can now multiply this to the derivative of our outer function. Okay, so to have more space, let us have this first. Let us move this in here. So we have the f prime of x is equal to 4, and then times the square root of x over 3x plus 1 to the power of 3 times the derivative of our inner function is this already. So we have negative 3 halves x to the 1 half, then plus 1 half x to the negative 1 half. So therefore, okay, and this is still over 3x plus 1 to the power of 2. So for this, we can now consider, we can now simplify further by multiplying the 4 in here, this one. The 4 can be distributed to the terms here. So that will be 4 times negative 3 will be negative 12 divided by 2 will gives us negative 6. So again, 4 times negative 3 is negative 12 divided by 2 will gives us negative 6. And we copy x to the power of 1 half, and then 4 times 1 half x to the negative 1 half will gives us 4 times 1 half will equal to 4 times 1 is 4 divided by 2 is 2, and then x to the negative 1 half, so negative 1 half, and then uh, this will be over 3x plus 1 to the power of 2, and this will be multiplied to this one, square root of x. And remember that the square root of x, the quantity of square root of x over 3x plus 1 quantity to the power of 3 can be written in this way, to the power of 3. But this time, since the square root of x can be written into x to the power of 1 half as to apply the power rule later. Okay, so x to the power of 1 half to the power of 3, okay, is just the same thing as this. So they are of the same concept. Now in this regard, we can now apply the law of exponents, the law that says that if we are going to multiply common bases, we simply add their exponents. So therefore, but I think we still have to simplify the numerator by uh, I'm sorry. The x to the power of 1 half has already a power of 3. So we cannot distribute the x to the 1 half to the terms in here. No, we cannot distribute them because there is a power of 3. So therefore, we just simply not combine, but simplify the denominators. So we have to rewrite negative 6x to the 1 half plus 2x to the power of negative 1 half, and then uh, times x to the 1 half to the power of 3, and this is all over. Remember that we have a common base which is 3x plus 1. Thus we just simply copy the 3x plus 1, and then 2 and 3 can be added or will be added because they are of the same basis. So therefore, this will be 3x plus 1 to the power of 5 already. And so far, this is our derivative of the given f of x is equal to the quantity of square root of x over 3x plus 1 to the power of 4. Okay, so let us have this last example. So again, we will be rewriting this first into its fractional exponent. So when we say fractional exponent from radical expression, so okay, just to recall, if you are given nth root of x to the power of m, this could be written in some other way, which is the so-called fractional exponent. So how do we write this nth root of x to the power of m to the equivalent fractional exponent? Is simply we just copy the x And then our radicand x to the m will refer to the numerator in the fraction, and the n there as an index is our denominator. So from square root of I'm sorry, from the nth root of x to the m, it is now x to the power of m over n. So therefore, the fifth root of 2x cubed minus x squared minus 4 will be equivalent to 2x cubed minus x squared minus 4 to the power of 1/5. Why 1/5? Because as our entire radicand, this understood that there is a 1 as our overall power, overall exponents. Thus, 1 will be our numerator and 5 is our denominator. So for this, we are now ready to get the derivative of the outer function. So our outer function derivative will be rewriting the 1/5 according to the power rule, then the derivative times the derivative, not the derivative, times the inner function, x squared minus 4. And remember, there is a 1/5 minus 5 over 5. Where did I get the 5 over 5? It is just simply equal to 1. And since we have a 5 denominator in here, so it's just the same thing as 1/5 minus 1. And then times the derivative of the inner function. So the derivative of the inner function is, okay, this will be 6x. So that will be 6x. And then the 2 minus 2. So therefore, this will be, so the next step will be 1/5 and then 2x cubed minus x squared minus 4 to the power of negative 4/5, because 1/5 minus 5 over 5 is equal to negative 4/5 times 6x minus 2. Now, so since this has a power of negative 4/5, so we can only multiply the 1/5 and the 6x minus 2. So this will be can be written in this way: 1/5 times 6x minus 2 times 2x cubed minus x squared minus 4 to the power of negative 4/5. So this will be 1 times 6x will be 6x over 5. And then 1 times negative 2 is negative 2 over 5. And then times 2x cubed minus x squared minus 4 to the negative 4/5. Or to further simplify, they are having the same denominator, so we can write 6x minus 2 over 5 and then uh, times the 2x cubed minus x squared minus 4 to the negative 4/5. Or if you would like to simplify the negative exponents, then this could be written in this final form. This will be 6x minus 2 over 6x minus 2 over 5 here, and then since we have a negative 4/5, so this will become 2x cubed minus x squared minus 4 to the power of positive 4/5. So this is our final derivative of our given number 6. Guys, I hope you have learned something from my video today, and then I hope before you will you will watch the next videos of mine, be sure you are done subscribing, and do not forget to leave your comment below. This has been Teacher Justina, and telling you to to keep on watching my videos for more learnings. Thank you and goodbye everyone.